Let us now look at two specific examples of micromixers. This is the first type of example where, and here you can see the view of the top view of the entire mixer. I have two liquids inlet, a liquid A and an inlet B, and they come together here in this region here, and then they are merged together and they move through a meander until they come at the outlet. And if you look a zoom in of this region here, you see that it looks like this. And this is actually a picture of the same thing. So what's happening here, because you see only one layer here, there's a second layer that's not drawn out. And I'll try to explain that, how that works, with actually my hands. So I have one layer, liquid A, in one layer now, it's a vertical layer. My liquid A comes in here over my arm, and I split it over my fingers. So my channel is split over my fingers. And then I have B coming in from the other side, actually from the top side, but it comes out of plane direction. So my fingers will interlock here. Every finger will interlock with another finger. And so I move my two streams, my A stream and my B stream, come together here. So every point, interlocking point of my fingers, I get one stream and another coming together, and then they move together. So I have a big stream A and a big stream B. I split them into small streams. At every small connection, I connect to each other. Let me draw that. So I have my stream A coming in here, and it's splitting in a number of small streams. I have my stream B coming from behind, and also splitting into a number of fingers. And now I'm going to interconnect these 2 points, and these 2 points, and these 2 points, and these 2 points. So here I get a mixture of red and blue. Here I get red and blue here and here. So what I'm doing actually is instead of having two streams and making two together, I split them, and then I have in this case 4 regions with interface area. So I go from 0 interface to actually 4 different streams with 4 different interface areas where I have diffusion. And this is how the mixer works. Another example of mixer is a famous one, is the herringbone mixer. And this mixer employs really the stretch and fold strategy. And now let me explain how that works. So the mixer consists of a channel. You can see that channel. And in the bottom of the channel there are V grooves. And actually you can see that perhaps, yeah, you can see that. V grooves. And the V grooves, they are not symmetric. So and you can see it actually here, actually in an even better way. So we have two channels with one inlet and another inlet, and this is a channel here. And then there's V grooves here. But the V is not central in the middle. So here the top of the V is a little bit to the left, and here is a little bit to the right. And these are grooves just in the bottom of the channel. So what happens with my liquid that moves into this channel? Again, I'm going to have to show that with my arms. Bear with me. So I'm coming in with 2 streams. And these streams, see, underneath they see these V patterns. So if I'm a stream and I see a groove in this direction, I will be forced to follow that groove. And this stream starts rotating according to the V here. So this stream starts rotating in this way, and this stream starts rotating in another. So I get 2 rotating streams within my channel. So this is now an out of plane, a channel coming from me towards you. I'm a fluid element flowing towards you, and I'm forced to rotate as I'm coming towards you. And the point where these two meet is not in the middle of the channel, it's slightly to the left side or the right side. So I have one big vortex here, and I have a small vortex here. So it goes like this something. So a big vortex and a small vortex. And then after a while, as I do that, after a while, I see my V changes. So now the middle point of the V moves now, instead of the left, it goes to the right side. So I had my small vortex and my large vortex, and now suddenly that changes, and suddenly where my small becomes the large vortex, and this becomes my small. Yeah? And after a while that changes again, this becomes the large and this the small. So I get each time 2 rotating flows, but the center of these 2 rotating flows switches all the time. And then we can see what it actually does. So I get my 2 rotating flows. So as long as they rotate, like between 2 points, between this point and this point, as they rotate, the liquid is really stretched. You know, every rotation stretches the two lamina over each other. And when I fold, then certain amount of, for example, this is my small vortex and this is my large vortex. If I now move and this becomes my small vortex and this is my large, then the whole region in the middle moves from the large vortex on the left side suddenly to the large vortex on the right side. This is kind of what I call the folding action. So every time I move direction, the part in the middle of my channel moves, is now not going around this vortex, but it's going around the other vortex. And that is, so the stretching is during just the rotation, and the folding is whenever I move from left V pattern to right V pattern, from a left-centered V pattern to a right-centered V pattern. And this is a way to create chaotic flow. So I have a two-dimensional flow, but I have a time change. The time change, the flow is not the flow is changing because at every point I force the liquid velocity to change.